All right, guys, welcome back to part 2 of the manifold build series. Let's get into it. So from here, we need to establish what we got to fit. So we calculated runner length in the last video. Now we need to see what's actually going to fit on these two engines and what the port angles actually are. So we talked about measuring port centerline. Now I want to see what the port projection centerline looks like. And how we find that is real simple. We're going to measure the floor angle relative to the deck face. That's the floor angle when I get it there. And then we're going to measure the roof angle and then split those two in the middle, and that's our port centerline angle. And we're going to do that on both now. All right, so we've got all our numbers. The Blue Thunders have come in, 6-degree floor, 15-degree roof. That gives us roughly a 9-degree above perpendicular centerline for the runner. Again, this is a 45V, so we'll be able to use that data, put that into CAD. The big block Chev, we've come up at 0 and 8, so that gives us a 4 degrees above perpendicular to the flange. 4-degree incline on the runner itself. So now we're going to get a measurement between the two ports, so the floor to floor, so we know what that distance is. So that way we can construct the runners and the port centerline, the port window height in CAD, and just see how the runner is going to dictate plenum volume. Again, the longer we get, the closer they get, the more crosstalk we get as well. So with these massive compression engines, we need to be careful of that. Same thing with the big block. Again, this one's making it a little easier because we're nearly twice as much up on the vertical height as far as perpendicular goes to the flange. And you can see it when you look at the ports. These actually come out on an angle where these tend to come out perpendicular to the flange. So same thing, we're going to get a center distance here between the ports. And then we'll go into CAD and draw this up. And yeah, let's go and do that now. But we'll get into it. So we're going to just go to a construction layer. Again, I'm not a CAD expert. This is sort of how I learnt. So if you want to add layers, you can do it here. You just hit them there or minus them. So you can go in, type con for construction, make it yellow. If you have a look at some of my drawings, I do all the bolts a different color, construction lines and all that sort of stuff, and if it's got water we'll make it green or whatever it may be. So alright, so we're in here. We're going to just start with our construction lines first. This is the first construction line there. We're going to hit that, and now I've got rid of the UCS, but what I'm going to do is just hit this symbol down here, and we're going to hit 0-0, which will put it on the center coordinates 0, 0. We're going to hit spacebar for one there and one there, and then hit escape. Alright, so now we've got our construction layer. So now we're going to go to our top white layer. We're going to hit line, and we're going to put it across like so. The head width for the big block Chev, which was 167.75. We're going to hit enter. Alright, so that's our line. Now we're going to do this line, but see it's only doing 90 degrees, so we're going to turn that off now, and we're going to go here. We'll make it 200 mil. But we're going to hit tab, not enter, so we can set the angle. So there's the angle there, and you can just type it in, 45 degrees. Not 35, 45, 45. Hit enter. If you can hear my dog snoring, that's my dog. Alright, so now we're going to do the same the other side. We're going to go up here, we're going to go again, 200, tab, and it's going to be 135. which is 45 the other way. Done. Alright, so now if we look at our 9-degree port window from the deck surface, we need to know this height here, from the deck to where the bottom of the port starts. So we can go into our dimension tool, we can hit here and come down, and we're looking at 57.15. So we'll just go 57 for now because it doesn't need to be super accurate. We're just trying to work out what sort of runner length we can get in. So now let's go back to our drawing. So we can get this line, start here, we'll follow that line up and we'll go 57 mil. We'll hit enter, and then we can come out on the angle that we need. Now we said that the port angle on the big block was about 4 degrees above the perpendicular height. So what I might do just quickly is cancel that. We'll go back to our construction line. We'll hit our construction line. We'll find the end of that. We'll come straight out here and we'll just make this, say, 200 mil again. We'll hit tab and we'll go 45. So that's now our perpendicular line from the floor of the port. So if the window starts there, so the window will be here. And we're going to do the other side, same on the other side. So we'll go back to this one, we'll go line, we'll follow that, we'll go up, and it was 57 mil. We'll escape out of that, we'll go to our construction, so we don't mix things up here. You can use dotted lines as well, but for now this will do us. We'll go 200, tab, 135, enter, escape. So now we know we're going to be 4 degrees but above the center line. Now being that this big block, unlike the Blue Thunder, the cylinder head is pretty much on size, so with this engine I can actually get away with a little bit more tilt up without losing too much horsepower, where the Thor heads, as you've seen, they're even down on CFM demand, so we're going to need a lot more port stability. So we're actually going to go under center line for the Thor. I won't do that in this video. We'll just stick to the Chev for now. If you want that for another video, I'll do it and then we'll explain why. But with this video we're going to go above the center line, so I'm actually going to make the floor about 4 degrees above center line, which if I had a 4 degree taper, that'll give us about a 2 degree above again, so 2 degrees up on our port center line. So what I might actually do just quickly is, so we've got that as our perpendicular. Let's just go to the drawing. We will go measurement. We'll just do a port measurement here, just so you can understand it. 68.5 we'll use. That's pretty close. So now we'll come here. We'll go 68.5. 135, check. And now we'll find the midpoint. So we'll come down here. Midpoint, yes, we have it. So line, there's our midpoint. We're going to come out of there. And we're going to set this, like we said, at 4 degrees. So 4 degrees on 45 is 49. And our rough length for the big block runner is going to be, let me just check here. I'll bring this up. So this is pipe max. So our total induction length is 13.47. So our port is 6.7, our runner is 6.7. Okay, so let's close them up. We're going to actually, what we're going to do quickly is we're going to offset that and we're going to put in 12 mil because this is actually our head plate thickness. So now the runner needs to be 6.7 inches, 6.7, times 25.4 is 107, minus 12, yeah, we might fit it, so 158 plus, okay, so about 170 mil off here, so let's get this line. We'll find the midpoint again, set a little triangle, that's our midpoint in the port. We're going to come up at about 170 mil. We're going to hit tab and we're going to go 49. Alright, and then escape. And we're going to do the same the other side. So let's go. Actually, we can choose a line. What was the port height again? Sorry, let me do this. 68.5. Alright. So here, no, we'll do it on the floor. Again. 68.5. Okay, and then we're going to come out of here. And we're going 170 mil, tab, and the angle is going to be 135 less 4. So 135, which will be there, which is 45, and then come up, so it's going to be 131. 131. Alrighty. So now we can see the distance between the two center lines, but now what we want to do is we can measure that quickly actually. So 73 mil, that's great. But now let's do a port floor line and actually we'll change it over. It matters. From here, the runner is obviously going to be around 150 mil. So 155, because we've got the aluminium and the head plate, and then I'm going to make that tab. I'll make that 52 degrees. Escape, and I'll do the same with the other side. 155 tab, and where did we say it was? 51, so it's going to be 129. Alrighty, so now we can measure this, and we've got 40 mil between the two at that angle. That's not too bad at all. If we project that line up, yeah. So that's the distance between the two runners. So we've got over 40 mil, which isn't too bad. So I'm going to give this a little bit of elevation. So now we're actually going to draw the runner. So we've got an idea of the length. I've already drawn it. But I'll just do it quickly to show you. So we're just going to go in here. I won't use construction. Well, actually, I might have to in this one, just quickly. So I'll show you how to do that again. Add. I'll put a con in here. Construction. And we'll make it yellow. Done. I'll turn that off now. And we'll select it. And I'll get the little hand, slide it over, escape out of that. It's our UCS, which we're going to turn off. And we're just going to do the same thing we did before with a construction line 0-0. Click the 90, 1 and 2, escape. Okay, and now what I'm going to do is we're going to go in and grab one of the port windows. We're going to copy that. And we're going to come back into drawing. We're going to paste it. Paste. We're going to bring that down and sit it on there. We're going to zoom. We can just go zoom extents. That brings us in. We'll zoom back out a little bit. Okay, so that's our port window. This should be exact, so if you have a look you can see it's still segmented. So what we're going to do is modify it. I leave it segmented in case you got to adjust radiuses, so I save both files. We'll hit join, so now it's a polyline or whatever they call it. Here, polyline. So now if we go, no, that's not what we're after. What I want is properties. So properties will tell us what sort of CSA we have, and there it is right there, area 3025. So now we're going to go into the Einstein app and convert that to inches. Alright, so we're in the app. I just want to convert the sizes quickly. We'll go into the bronze free calculators and we'll just go to conversions 1. It should be in here. So we had 3026, I think it works out. Yep, so as you can see our port entry is 4.69. Alright, so we'll go back to the CAD now, and we know what the area of the window is, and now we can do the top area as well. Alright, so we've got the port laid out. We know the size, so we know the area of that is 4.69. So now we're just going to do the, and we'll close that. We're going to use the offset button up here. So we're going to get rid of that. And let's hit it. We're going to enter what the offset is, so we'll just try 4.5 mil for now, and we're going to offset that to see what the area. So now we can hit that. We'll go into properties, we'll scroll down. Our goal is going to be, again, being big block, so let's have a look at our data. The analysis come up if we look down here. Tunnel ram with a direct line of sight. The top size is about 6-7. You're generally using up around the top size with a max effort type engine. You can see with a poor line of sight we're up near 8. But I'm going to be a bit shorter than that, being that it's EFI, because I want to increase the airspeed. The factory manifold's actually shorter, and it's about 6.6, and we're going to run about 665 CSA at the top of the window. So we actually need 4,300 square millimeters. So you can see here we're still a little bit low. What we're going to draw is basically this. So we've got the port window now, and we've got the plenum opening. So now we're going to go and hit our control to get a better view. Our what is it? Global government, global what's here? And we're going to go into 3D modeling now. So this will change a lot of this. The runner length is going to be 150 mil long, so we're going to send this up on our Z axis. 150 mil, so 6 inches basically. And we can zoom out a little bit. There we go. Now we can turn our construction layer. We'll go to our white, turn our construction off. So what I tend to do, depending on the runners, I don't, we'll go to the offset unit again, I run the bottoms at around 3.5mm thick. And depending on what it is, we'll run the top anywhere from 4.5 to 6mm. Some of the blown stuff we run thicker, around that 6mm, but this one we're going to run at 4mm up top, because we're obviously trying to keep weight out of it as well, and that should be more than thick enough. So from here, all we're going to do is going to go to loft, and we're going to tap that. I should not do the inside first, inside to inside, and then hit enter, enter. We'll hit loft again, hit the outside, and the outside, hit enter, enter, get out. And then we're going to go and turn on X-ray so we can actually see, and there's the shape basically already. That's the tapered runner. Now what I haven't demoed, which I might do if you guys are interested, let me know. I'll show how I shift the window across, which is what I actually did with these big block runners. So this is the finished unit, and you can see how this wall is dead straight, but this wall leans out. So I actually offsetted the window before we constructed this runner, so it has taper in this side but not in this side. That way we can have two runners coming in under the throttle bodies. I'll do the same with the carbureted stuff. So we'll have a look from the bottom. So yeah, you can see the taper there. You can see it's slightly offset one way. It's only about 3 degrees. So and that's basically the runner. So that's what we've ordered, and they will be here this week. So yeah, if you want another video of the next steps, let us know, and we'll get into basically setting the face angle here. So in this drawing, we're going to work out exactly what angle we can run here, because as I said, with the Thor heads being a smaller head, I actually want it under the port center line, because that'll stabilize the short turn in the head, because the head's already fast. So but yeah, this is just a quick idea, using construction lines and normal lines to sort of work out where the runners are going to be, and if you can actually fit in, and how much you can tip them up. Some people say up to 15 degrees. I don't like that on fast cylinder heads, because the problem with an angle is it isn't relevant to airspeed. 15 degrees at what airspeed? At 200 feet per second, we might only get 2 to 3% cross-sectional area shrink as the air transitions and changes angle, but at 300, 350, we might end up with 10% reduction in that window cross-sectional area as the air has to change direction. But I'll also show you how when we fabricate that, we can compensate for this change in direction as well. Alright guys, yeah, if you want to see more of this type stuff, we're also going to get back to our induction series, but we've just had a lot going on. We're trying to meet a drag week target for one of our customers, and we've also got another pro stock intake happening in the background that we're trying to make a race in about 4 weeks. So we are absolutely flat knackers. So I will try and get back to it, and yeah, thanks again guys. Cheers.